Chapter 4, Lesson 2 of Pre-Calculus, and we want to tie together what we've talked about in the first two videos. We talked about the trigonometric ratios, we reviewed those SOHCAHTOA, and then we looked at the reciprocal functions, the cosecant, secant, and cotangent. Then we reviewed the 45, 45, 90 triangles and the 30, 60, 90 triangles. Now we want to put those together and show you what the trigonometric ratios are in those two triangles. And these will be very important trigonometric ratios. They'll be ones that you really need to memorize, because we will be using them extensively when we look at these trigonometry in the terms of a circle and putting these angles on the unit circle. And so I'm going to quickly run through those, where those ratios come from, and then so you can see those, and then we'll look at how do we find the trigonometric ratios of triangles and sides whose sides aren't those special triangles. Okay, let's look at the 30, 60, 90 first. And in our 30, 60, 90, you remember this is the 90. This is going to be my 30-degree angle, and this will be my 60. And you remember from our discussion that the shorter of the two sides is opposite the 30, so this is going to be a 1. The longer of the two sides is opposite the 60 and is radical 3 times that 1. And then the hypotenuse is twice the shorter, which is 2. So in this triangle where this is 1, we have this. Now that we have all our sides, we can write our ratios. So we'll write the sine of the 30-degree angle first, and remember this is where theta was, and so that's where the angle measurement goes in, and it's the opposite side over the hypotenuse. And then we can write the cosine of the 30-degree angle, and that's the adjacent side over the hypotenuse. And then the tangent of the 30-degree angle is the opposite side over the adjacent. Now, a note about this tangent ratio: we have a radical in the denominator, and as a final answer we would rationalize this. So sometimes you'll see it looking like this, and sometimes you'll see it looking like this. You're going to need to be able to recognize both. Okay, so those would be the sine, cosine, and tangent of the 30-degree angle. Then if we wanted to look at the reciprocal functions, you remember it's simply the reciprocal ratio that we have here. So the cosecant of the 30-degree angle is simply the reciprocal of what I have here, which is 2 over 1, or 2, hypotenuse over opposite. The secant is the reciprocal of the cosine, so this would be 2 over square root of 3. And then again, you may see its rationalized version looking like that. You'll want to be able to recognize that as well. And then the cotangent is again the reciprocal of the tangent, so we take the reciprocal of that, radical 3 over 1, which is radical 3. So those would be the sine, cosine, or the 6 trigonometric functions of the 30-degree angle. Let's take a look at the 6 trigonometric functions of the 60-degree angle, and then we'll look at them together and see if we can't see something that's going on, which means you probably should, because I just said it, so maybe you can check it out or see what's going on before I say it. Okay, the sine of the cosine, sine of the cosine. Man, I got all confused when I was talking about that. All right, sine of 60. So again, we take the opposite over the hypotenuse, which is radical 3 over 2. Now, before I go on, look up here at the 30. Which one of these ratios is this? Same as this one. Well, notice that the cosine of the 30 and the sine of the 60 are identical. That's very interesting. All right, let's go ahead and do the reciprocal function here. So the cosecant of the, I'm looking up here, the cosecant of the 60 then is the reciprocal of this, which is 2 over radical 3. Now which one up here is? Well, look at that. The secant is the same as the cosecant. So the secant of the 30 is the same as the cosecant of the 60. Interesting. Let's look at the next one. So we have cosine of 60 is going to be the adjacent side over the hypotenuse. Now which one up here? Well, the cosine of the 60 is the same as the sine of the 30. Interesting. If we do the reciprocal function right here, we're just going to take the reciprocal of this, which is 2, and again you'll notice that that is the same as the cosecant of the 30. And then if we do the tangent of the 60, opposite over adjacent, radical 3 over 1. Notice that is the reciprocal of this. And then if we look at the reciprocal function, the cotangent of the 60 is the reciprocal of what I have here, 1 over square root of 3. You notice that's the same as the tangent of the 30. So the tangent of the 60 is the same as the cotangent of the 30, and the cotangent of the 60 is the same as the tangent of the 30. So that's kind of the connection between sine and cosine. Sometimes people ask me, where does the word cosine come from? That's kind of a weird word. Well, cosine actually comes from two words put together. The cosine means the complements sine. And you remember, complementary angles are angles that add up to 90. So when we're looking at cosine of 30, we're looking at the complements sine. So actually we're looking at the sine of the 60, because the 60 degree is the complement of this 30. So if I look at the sine of its complement, you'll notice that's what I have. So this complements sine means what's the sine of the complementary angle to this one? Well, the complementary angle is 60. The sine of the 60 is radical 3 over 2, so the cosine is radical 3 over 2. So it's an interesting connection that you can see there. We won't talk a lot about it, but just thought I'd point that out to you moving forward. So let's take a look then at the 6 trigonometric functions of our 45, 45, 90 then. Now in our 45, 45, 90, both angles are the same, and so because both angles are the same, then both sides are the same. That's why the legs in a 45, 45, 90 are the same. And then again, if we apply the Pythagorean theorem, this becomes radical 2. So radical 2 times either side is going to give me my hypotenuse. So let's go ahead and quickly look at our ratios. So the sine of a 45 degree angle is the opposite side over the hypotenuse, which is 1 over the square root of 2. And again, the rationalized version you'll see is radical 2 over 2, something that you'll need to recognize. If we go ahead and do the reciprocal function right here, the cosecant of 45 is simply the reciprocal of this, which is square root of 2 over 1, or square root of 2. Now, the cosine of 45 is going to be the same because both sides are the same, so the sine and the cosine are going to be the same. So in a 45, 45, 90, really, you only have to remember one ratio. And again, the rationalized version would be this, and then the reciprocal of the cosine would again be the same because the sides are the same. Then we have our tangent of the 45 is opposite over adjacent, which is 1 over 1. And the reciprocal function of that then would be 1 over 1 as well, or 1. So you can see, because the sides are the same, the 6 trigonometric functions are pretty easy to remember. You only have to really remember two things. 1 over square root of 2, because that's the sine and the cosine. And then the tangent is a 1. And then the reciprocal functions are easy to figure out from there. Okay. So in those 30, 60, 90, and the 45, 45, 90, all of those trigonometric ratios are vitally important that you are quickly able to recognize those. So when I say sine of 30, you should automatically go, oh, that's a half. If I go cosine of 30, you should go, okay, that's radical 3 over 2. And what's the sine over 45? 1 over radical 2. Cosine over 45, 1 over radical 2. You should be able to say them that quickly and know them. And the better and the quicker you get at that, the quicker you'll be able to do these trigonometric problems that you'll be asked to do, and the easier your trigonometry becomes. Okay? In the last section of the video, we want to take a look at what about triangles that aren't special? What about the ones where their sides aren't these nice special triangles? How do we figure out those, or what kind of problems am I going to run into? So let's take a look at those. So for example, let's say that we're given the sine of some angle is 5 over 6. I want you to give me the cosine and the tangent and the cosecant and the secant and the cotangent of that angle using just this information. Well, I can get part of this if I remember that these are reciprocals of each other. So I know then that the cosecant is going to be 6 over 5. So that's one thing I should be able to do quickly. How do I get the rest of these ratios? Okay, well, we have to remember what these ratios are. And so if we draw what we can call a reference triangle, and we'll label the sides based upon what we know. The sine ratio, you remember, is the opposite side over the hypotenuse. So if I take one of these two angles, and it doesn't matter which one, but they usually take the one down here, and let's say that's the theta angle that we're talking about, then this ratio represents the side opposite that angle over the hypotenuse. So the side opposite of this I know is 5. And I know that the hypotenuse is 6. Well, knowing 2 of the 3 legs, I can then apply the Pythagorean theorem to figure out this. Because once I know this, I can then write all of these other ratios, because all of these other ratios involve this adjacent side. Okay, so I need to know what it is. So by using a reference triangle and labeling the sides based upon the ratio that I'm given, I can then use Pythagorean theorem to determine the length of the side I'm missing, and then I can do my other ratios. So I know that the Pythagorean theorem, 5 squared plus x squared is equal to the hypotenuse squared. So x is going to be the square root of 6 squared minus 5 squared. So x is going to be the square root of 36 minus 25, which is 11. So the length of this side is the square root of 11. Now don't turn that into a decimal, leave it as a radical. Now that we have that, we can write the rest of our ratios, because the cosine is the adjacent side over the hypotenuse, and the secant is the reciprocal of that, and the tangent is the opposite side over the adjacent side, and the cotangent is the reciprocal of that. So based upon the one angle that I'm given, I'm able to determine the length of the other side using the Pythagorean theorem, placing these sides where they go, and then I can write the rest of the ratios. Okay, so that wraps up what we're going to need to do in this lesson. Make sure you read your book, particularly the section about grapher error, or most common errors that are made when students are using their calculator to calculate then these trigonometric functions. There's some very important things you need to know, very important things you need to remember and be aware of, so that when you're entering values into your calculator and you're getting these numbers out or errors out, you have some idea of what the problem might be.